Welcome back to Applied Physics Lecture Series, Unit 4 Lasers, Lecture 5, Helium Neon Laser. So if you classify the lasers, so based on the state of active material, already mentioned we are having three types of lasers. One is solid state laser. So example for the solid state laser is UV laser. We discussed that one in the previous lecture. And now second type of laser is gas laser. So example for the gas laser is helium neon laser. Already we know what is meant by this active state. Active state or active material. So active material is nothing but the material which undergoes stimulated emission. As a result, it produces laser light that will be called as active material. Here the active material is in the form of solid. That's why the active material is in the form of solid state laser. Here the active material is in the form of gas. That's why it is considered as gas laser. Here the example for the gas laser is helium neon laser. Now I am going to explain the operation of gas laser by taking helium neon laser as an example. So this is the first successful gas laser which was operated in the year 1961 by the scientist A. Javan. A year later to the first successful operation of a laser, which is nothing but ruby laser. If you prepare the list of lasers, the first successful gas laser is nothing but helium neon laser, which was operated in the year 1961 by the scientist A. Javan. If you prepare the overall list of lasers, its place is second. First one is ruby laser and second one is helium neon laser. This is the experimental setup of helium neon laser. Observe there are 5 parts. First part is the part which is represented with number 1 is gas discharge tube, which is made up of with quartz material. And the second one is on the two sides of the gas discharge tube, which is nothing but a quad tube or Brewster's windows. And 3 is nothing but back mirror, and fourth one is front mirror. That means 3 and 4 are nothing but mirrors. Both are concave mirrors. One is a thick concave mirror, another one is a thin concave mirror. And the fifth one is initial light medium. That means light is coming out, so that is nothing but this one. In gas lasers, such as helium neon, the atoms are characterized by the sharp energy levels when compared to the atoms in solids, which are having broad absorption bands. Helium and neon laser consists of a long discharge tube, already mentioned, which is filled with a mixture of helium and neon gases in the ratio 10:1. So the material which is present in the least concentration will automatically considered as active material. Here, neon atoms are present in less concentration. For every 1 neon atom, we are having 10 helium atoms. That's why neon atoms are present in less concentration. That's why neon atoms will act as active material. That means they will undergo the process of stimulated emission. Electrodes are connected to a high voltage source, which is operated at 10 kilovolts. Laser action is due to the neon gas, so helium atoms helps the excitation of neon atoms. The discharge tube consists of windows placed on both sides at a specific angle called as Brewster's angle. Here that angle is theta equals to tan inverse of n. Two mirrors are also present on both sides of the discharge tube. One mirror is fully reflecting and other one is partially reflecting. So I will explain all these. First of all, so the gas tube, first one is the part 1, which is nothing but a gas discharge tube, which is made up of with quartz. And inside the quartz tube, we are placing helium and neon gases in the ratio 10:1. And helium and neon gases were placed in the discharge tube by maintaining the entry level pressure conditions as 1 mm of Hg and 0.1 mm of Hg respectively. That means, so first of all, we will introduce neon atoms into the discharge tube by maintaining the pressure of the discharge tube as 0.1 mm of Hg. Later, we will introduce appropriate number of helium atoms by increasing the pressure of the discharge tube as 1 mm of Hg. And the two ends of the discharge tube is having a special type of windows called as Brewster's windows. Those are slanted at a specific angle, theta equals to tan inverse of n. Here n is the refractive index of the material, which is used for the manufacturing of windows. What is the purpose of these special windows? To get the plane polarized laser output. We know that laser is a narrow beam of light and it is traveled in a straight path without reduction in the intensity. That's why to get such a plane polarized laser output, both the ends of the discharge tube are having a special type of windows. Those are slanted with specific inclination, which is nothing but theta equals to tan inverse of n. Those windows are called as Brewster's windows. Usually, alkali halides like NaCl will be used to manufacture those special windows. And coming to the Part 3 and 4. Part 3 and 4 are nothing but similar. The two sides of the discharge tube are having two concave mirrors. One is the thick concave mirror, other one is a thin concave mirror. So part 3 is nothing but thick concave mirror and part 4 is nothing but thin concave mirror. So simply it will be as a combination of mirror system. What is the purpose of mirror system? So here the discharge tube is having openings at both the ends. That means windows are present on both the sides. So that's why, so if any light radiation is coming out towards the thick concave mirror, which is numbered as 3, so thick concave mirror does not allow any light radiation to pass. Simply it will reflect back the entire light radiation coming towards it into the lasing medium. That's why the efficiency of the laser light will be increased. For that purpose, we are using mirror system. And at the bottom of the discharge tube or sometimes at the top of the discharge tube, two electrodes are there. So those are usually known as anode and cathode. By applying a suitable potential difference between those two, we will lift the active material to the higher energy levels. So here the active material is nothing but neon atoms. So by applying a suitable potential difference between the anode and cathode, that means in between the two electrodes, neon atoms are reached to the higher energy level. That is nothing but pumping process. And fifth one, so that is nothing but light beam. So along the thin concave mirror side, that is nothing but number 4, the actual laser emission takes place with the following characteristics. Again, the color is red in color, but the wavelength is 6328 angstrom units, and here the output power is the range of 5 to 50 megawatts, and the angle of divergence, because gaseous medium is there, it is up to 2 degrees. See here, so all these processes, right from pumping, followed by population inversion, stimulated emission, amplification, and the last one is laser production. All these are represented with a specific energy level diagram. So here you can able to see the energy level diagram. So if we consider this energy level diagram, so consider it as a two parts, left hand side and right hand side. Left hand side part is the energy level diagram of helium atoms, and right hand side part is the energy level diagram of neon atoms. First, I will explain left-hand side portion. So at the F1 is the energy level, ground state or lower energy level of helium atoms. Majority of the helium atoms are present at F1 energy level, which is nothing but ground state. So because they are present in large number, therefore by means of certain number of collisions that takes place between those are called as electronic excitations. As a result, some of the helium atoms are reached to the F2 energy level and some of them are reached to the F3 energy level. So here F2 and F3 are the higher energy levels of helium atoms. So once the helium atoms are reached to the higher energy levels during that electronic excitations. Then coming to the right hand side portion, which represents the energy level diagram of neon atoms. Here we are having a total of 6 energy levels: E1, E2, E3, E4, E5 and E6. Out of these, E4 and E6 are the higher energy levels. E5, E3 and E2 are the metastable states, and E1 is nothing but ground state. So here the neon atoms, so they are present initially at the ground state, which is represented with E1. By means of pumping, so neon atoms are excited to the higher energy levels, E4 and E6. Observe F2, F3 higher energy levels of helium and E4, E6 higher energy levels of neon are having almost same energy. That's why some of the helium atoms transfer their energy to the neon atoms to start the stimulated emission of neon atoms. Once the stimulated emission starts, then so many transitions that takes place. One is from E6 to E5 with release of wavelength 3350 angstrom units, and second transition is from E6 E3 E6 to E3, which produces a wavelength of 6328 angstrom units, and another transition from E4 to E3, which produces 1150 angstrom units. Out of these three transitions, so the transition from E6 to E5 and E4 to E3 are neglected because those wavelengths are not in the visible region. And there is one more transition from E3 to E2, which produces a wavelength of 6000 angstrom units, but the transition takes place in between the two metastable states. So that's why there is a spontaneous emission. As a result, spontaneous emission is not responsible for the production of laser, even though we are having wavelength 6000 angstrom units in the visible range. Therefore, out of these four transitions, we will ignore the three transitions. The remaining transition is only one, that is E6 to E3, which is considered as a stimulated emission, and the corresponding wavelength is 6328 angstrom units. Then all those are reached to, all the neon atoms are reached to the U2 energy level. They are assembled at one place, means being large in number, they collide with walls of the discharge tube and they will lose energy to the discharge tube. Thereby they will be reached to the E1 ground state. So at the time of neon atoms reach to the ground state E1, already helium atoms are present in F1 energy level. That is the ground state of helium atoms. Again, electronic collisions or electronic excitations, they will be reached to the higher energy level. And once neon atoms are present to the E1 energy level, again we will conduct the process of pumping. Those are raised to the higher energy level. Therefore, such a process of excitation and de-excitation takes place continuously. As a result, we will get continuous laser light. This is the way of operating gas laser. So by taking helium neon laser is an example. And when power is switched on, electrons and ions produced in the discharge tube collide with helium and neon atoms. Helium being lighter gas and gets excited to the more readily when compared to the neon atom. So energy levels F2 and F3 of helium is close to the energy levels E6 and E4. So when helium atoms collide with neon atoms, they transfer their energy. So they will start the process of stimulated emission, and E6 is the highest energy level. Transition from E6 to E3 produces a characteristic wavelength of 6328 angstrom units. Other two wavelengths are not in the visible range, that's why they are eliminated. Brewster's windows made up of glass quartz absorb. These are all the wavelengths. Mirrors are providing the optical feedback. And so if we consider the applications once again, so ruby laser, measurement of distance using pulse echo techniques and drilling of high quality holes. And helium ion laser is used in the applications of meteorological applications, barcode reading, etc. And another example for gas laser is carbon dioxide laser, that is used for the purpose of welding and cutting. And argon ion laser is there, that is also used for welding retinal detachment. And there is a semiconductor laser which is used for laser printer. Thanks for watching.